Okay, you have. That's the problem. So please keep your mics off. Otherwise, it would keep me in great trouble. I have to disallow the mics. I prefer that mic should be on. Mhm. That's the problem. Please, this. Anyway, keep your mics off, right? So, as and when you want to ask something, uh, whose mic is on? Whose
Misala
mic?
Manjunath Reddy.
Uh-huh. Just wait. Um, keep your mics off, please. Anyway, so let me share the screen and then we can kickstart, right? It is already 10:28. No issues. Just give me a minute. Do let me know when you would be able to see my screen. I hope it is visible now, isn't it?
Yes, sir.
Yeah.
Great. So, yeah, right. Okay, I think we can start with officially it has to be 10:30. Anyway, so so I'm Professor Pankaj Agarwal, right? So uh, I'm I'm not the regular faculty at BITS campus. I'm the off-campus faculty member on a visiting basis. I'm the guest faculty here, and I'm professor and have experience of more than 25 years, and have been dealing students like you at BITS Planning from last 7 to 8 years, I hope. So and I happen to be in the domain of AI/ML deep learning for quite a bit long now. So let's see how interesting this entire journey of yours would be with me. And I prefer to take a lot of examples, prefer to have a lot of working examples. Although this first session would be a bit of the introductory part. So that is how I would like to take up this particular course. So previous semester also I took this particular course. So what I'll do is at the end of the session, I'll tell you that where I would be putting all the contents. I'll be putting the contents into the file section of Teams. I'll I'll let you know what I'll do, and I'll give you enough examples and maybe some practical sheets as well. So those who would be interested, they can do some kind of practical sessions as well. So it's all the sessions would happen on the standard context. So there are standard slides, as you all are aware. So you can refer to the contents. So all the contents would remain same, right? So give me a little bit of the course logistics. This would be a kind of the thought process that we would be giving you during the entire structure of the course, right? So roughly there would be 16 sessions, but divided into these kind of major thrust areas that we would be covering. Okay. And I hope you have already the syllabi with you, isn't it? I hope my voice is clear and crisp. Any issues?
Oh, no,
No,
sir.
sir, it's perfect.
All good, sir. Thank you.
All
Yeah.
good. Thank you. Thank you so much. Um, Test book, I mean, you have this link with you, so I would be giving this slide so you can always refer to it. I'm not sure how many of you still prefer um, books in a physical form. So, I mean, both the options would be available. You can purchase this if you want. So, otherwise, slides and the open contents which are available today, they should be good enough. But still, we would prefer that you should refer to these two uh, online references that we have given to you, right? You must be aware, or with the time you would get acquainted with this. This would be the valuation components, right? I hope you must have idea about this and you have been told about this, right? Um, so all these would be available with your LMS, Takshila, where you would be able to get handouts. I think you must have opened your Takshila, right? Did you have happen to visit that
Yes.
LMS? Yeah.
Yes,
Yeah.
yes, sir.
So
It's
yeah.
there.
Yes, sir.
So if you do not find anything right now, so with the time the course coordinators would be doing that, right? So not an issue. And lecture recordings would be available as well. And I mean, this is something that to ensure that all the submissions of grid components must be result of your original effort. That is something I hope you understand the ethical issues as well, right? So any queries in case, I mean, she would be, I mean, Shita, I mean, try to contact IC, right? Who's the overall coordinator for this particular course, right? And specifically mention if anything related to this particular course with the prefix DNN, right? So let's start, huh? And hopefully, if there's any query in between, you can either you can come in between. Let's see if the voice enabled interruption would be good enough, then we would continue with this. Otherwise, we would switch over to the conventional way of that you can put your queries into the chat, right? And from time to time, I'll come back and see the chats, right? Anyway, so what exactly is deep learning? So we'll give a very classical definitions first to get the basic understanding out of it. So when I talk about deep learning, I hope we have some kind of connections with the terms called AI, machine learning, and deep learning. So we'll try to establish that definition linked with these main components because otherwise the definition of deep learning would be not complete. So what I say is that deep learning is a type of machine learning, right? So automatically I'm saying that it is a subset of machine learning, right? So a type, so machine learning is a technique, everyone knows it. So deep learning is one of the techniques of the type machine learning, right? Which is based on the concept of artificial neural networks. So ultimately, deep learning is a type of artificial neural network based on the which comes under the broad technique of machine learning, right? We'll talk about what exactly the broad technique means, right? So deep learning is actually a type of artificial neural network which comes under the broad category of machine learning in which multiple layers of processings are used, right? With the time I will let you know. So obviously the basic understanding for deep learning is the basic understanding of artificial neural network first. So probably when we would start with after the from second session onwards, we would actually start with basic concepts of artificial neural network, and we would cover one or two basic artificial neural networks first. Okay, so artificial neural network is something that we would like to understand first, and then the extension of artificial neural network would be the deep learning, and what way we would try to understand that. So that extension is normally in the form of where we would have multiple layers of processing, which are used to extract the progressively high levels of feature. So what do you mean by progressively high level of feature is, suppose there's an image I have to recognize, suppose a particular animal, suppose dog. So there would be multiple layers in which I would do that, right? And that is how human also do that. Please switch off your mic, please, anyone who is on, right? So for example, in the initial phase, you know, I might look at the boundaries of the object first, right? I would try to extract what are the boundaries, what are the upper level features. At the second level, I would try to get into the more details of the features. And the third level, I would like to get into more details of the features. So that is how I would learn, and that is how any neural network works. So with the time, we would let you know that what exactly layers are, in case you're not aware about neural networks at all, right? So we would get into the details of the features, more and more details of the feature, once we would increase the level of, I would say, processing through multiple layers, right? So deep learning is a method of artificial intelligence, I told you, that actually teaches the systems to process the data in the same manner which human does. So it is absolutely inspired by the human way of learning, right? So wherever, whatever concept we would talk about in artificial neural network or deep learning, there is absolute analogy with the actual human based brain, right? You would be able to draw that analogy. So all the analogies or all the concepts in deep neural networks or the artificial neural networks comes from human based brain, right? They inspired by human brain, right? So with the time you would be we would be letting you know that the specific analogies and how the different kind of methods work in the neural networks and the deep learning. But the idea should be very clear to you that deep learning, which is nothing but artificial neural network, is completely inspired by the way human learns and way the human approaches to a solution, right? So deep learning is a machine learning technique that teaches the computers to do what? To do what comes naturally to humans. That is, learn by examples. So when I say that, when I say that deep learning is a machine learning technique, right? When I say what? Deep learning is a machine learning technique. So the analogy is that machine learning talks about that learn by examples. And learning by example is one of the major way of learning by humans. That is what we do, right? For example, I have to learn something. If a child has to learn how to recognize digits, so he would be trained on it, right? He would be given a lot of examples. So learning also a technique that learns by examples, right? So I hope you would be able to establish the connection. I'll give you one diagram also, that what exactly where each of these components, that is machine learning, artificial neural network, and deep learning sits, right? So deep learning, in a way, is a subset of machine learning
Hello,
technique,
sir.
Sir, your
Sorry,
voice
Sir,
sir.
is
Your voice is
sorry.
breaking.
breaking in between.
which is essentially
Your voice
Sir,
is breaking
sorry,
in
your
your
between.
voice
voice
is
is breaking.
breaking.
Still, it is,
Sir, you are not audible to us.
Yes,
it-
same here.
just wait,
Same here, sir.
it's still the problem.
Yeah, voice is breaking in
Yes.
Just
between.
wait.
Yes, sir. Sir, it was good and then it broke 30 seconds back.
Yeah, right.
It is now fine now.
It's still
No, it's
breaking,
still
sir.
the same issue.
No, sir, not fine yet.
It's the
Okay,
fluctuation.
just wait then. Let me try. What's the problem?
not able to see your
I
shared
think
screen
now
also.
it's okay.
So it is not breaking in between, but not continuous.
Okay, I
That's the
mean,
same
is
level.
it fine now?
Yeah, it
Now
is
it
good.
is
Yeah,
fine.
better now,
Yeah,
sir. Better
now
now.
it's okay,
Maybe you
sir.
can continue. Yeah.
Okay, okay. So we were up to the definitions of deep learning, right? And let me start the point again. Just wait. And so in a way, I told you that deep learning is a subset of machine learning, which actually is a neural network with 3 or more layers. So we would talk about this specific thought process. What do we mean by layers later on, right? So these are the basic thought processes that I gave about deep learning. So this is just the kickstart, right? You were given the thought process about some of the components, deep learning, machine learning, and artificial neural networks. Let's get more details, right? So the idea would be, as I told you, that as you would keep on increasing the layers, so every layer is somehow linked with the level of feature extraction. Uh, we'll be able to let you know about this in more details later on. So still very early stage. So layers actually, in every layer we would be able to increase the complexity level, right? And why this deep learning is being named as deep learning, because of the concept of these layering concepts, right? So there are concept of layers in neural networks. So we'll come to that, right? So this was the first page that we talked about, where we talked about the definitions of the deep learning. Let's talk a little bit about this slide where it gives you a clear picture where each of these components sits around. As you can see, the superset is obviously the artificial intelligence. So artificial intelligence is basically a science. Yeah, it's basically a wider concept. You can't say that it's a technique, right? It's a wider concept. It has become a science today, right? Machine learning is one of the ways, one of the techniques that enables me to achieve the concepts or achieve the 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 thought process that artificial intelligence talks about. What artificial intelligence talks about is that I want to become smarter. uh, I, my learning should be smarter, right? My learning should be automated, right? So machine learning is one of the ways that makes or allows me to achieve the concepts of artificial intelligence. Is that clear? And within the machine learning, you can see that the subset called the neural network. So obviously, so machine learning says that learn by examples, right? Machine learning says what? Learn by examples. My voice is clear now.
The voice is clear,
Yes,
but
Yes.
then
yes,
it
sir.
is
Now
there
it's
is a
clear.
Lag
lot
is
of
there.
lag between the
Lag is there
slides
for
and
me.
the voice.
It lags in between. I can understand that.
But
But
the
it's
slide is
managed,
Uh,
sir.
lagging behind.
No.
What? Yeah, slide
Yeah.
is lagging, sir. Otherwise, we can hear your audio.
okay, because I have tried whatever I could do with network. Mm,
I think this is
let me know. Yeah,
currently it is better, so I think we
yeah,
can continue.
It's fine,
Yeah,
sir.
we
I
can
think
yeah,
continue maybe.
your
yeah.
explanation
So
is
machine
better.
learning,
So
yeah, perfect, perfect. Thank you. So machine learning. So whenever the thought process of machine learning comes to your mind, as far as we are talking of this particular subject, deep learning, think machine learning in the context of learn by examples, right? That particular approach of making the system intelligent. So I'm trying to make my machine intelligent by learning the examples through experiences. And machine learning is one of the approaches to achieve artificial intelligence, see, in the systems. And artificial intelligence is all about making the machines intelligent, right? Not always through learning, to be very frank. It might talk about that. See, understand this concept, what I told you, when I talk about artificial intelligence, it does not mean that learning would or that smartness would come to the machines or the capability to the machines would come only through learning. It can be through other ways as well, right? I'll talk that later on in one of my slides. So learning is one of the best ways to make machines smarter, right? There can be other ways as well. I'll come to that later on, right? So machine learning is one of the ways to achieve artificial intelligence by what method? By learning by examples, through experiences, through training, through learning, right? Neural network is again one of the techniques in machine learning that enables us to achieve the thought process of machine learning. That is, learn by examples or learn by training, right? So neural network is one of the basic techniques. And as you know, there can be other techniques or other algorithms that are used in machine learning. I hope you're aware of it. There are supervised methods, there are unsupervised methods, there are reinforcement learning methods that we all know in machine learning, right? Deep learning is yet another subset of neural network, which primarily focuses on very huge problems, complex problems, where the extraction of features is a major concern, right? So it would only talk about very complex problems. For example, if we talk about some of the problems, specifically when we used to work on images, videos, right? So those complex problems are somehow dealt with deep learning, which is a part of neural networks, right? Data science is, as you can see, the diagram gives you a very clear picture. Data science is somehow has a touching points or has some kind of overlapping concepts with artificial intelligence, machine learning, right? Isn't it? Apart with neural network. So data science actually is different science, definitely, right? Which is basically inspired by that how the data needs to be that how the data needs to be. It talks about data. So that's the reason why data science. It's a science about data. So it would talk about. So it's not only the algorithm which is important. No, the data has its own level of complexities and has its own level of problems. So data science only talks about from the starting stage of how the data needs to be presented, extracted, everything. So the entire cycle about the data. So data plays the most important role in machine learning. So machine learning, as you know, that we must have good data, right? So we will talk about these concepts later on. I told you that artificial intelligence is not only about machine learning, right? It is not only we cannot make the systems smarter only by learning mechanism or only by the way human learns. There are other ways to or other approaches for artificial intelligence. So, and on the right hand side, you can see that there are other approaches which are well known in the books, right? They are rule-based systems, although these have become little bit of obsolete these days. Not absolute, but still, with machine learning advent and all those things, I mean, these techniques are not as much used the way it used to be. There are search and optimization algorithms, there are knowledge representations, there are planning systems, there are evolutionary algorithms, fuzzy logic systems. So these are some of the typical classical approaches of artificial intelligence, right? And machine learning is something which has dominated in the last 20 years as such. Okay. Any questions on this?
Sir,
Any
sorry
thought
to
process or
disturb you,
questions?
but
Yeah.
So,
like I have in doubt, what is the difference between the neural networks and the deep learning? Like that both are the
That we would
subset
come.
of
Yeah. So
machine
actually,
learning.
yeah. So bache, deep learning, I told you when I talk about neural networks, right? So neural networks, basically, you can say that it would use the same analogy to solve a problem the way human mind does, right? First,
Okay.
understand that concept. Okay.
Yes, sir.
Now, in order to do so, there are certain complex tasks, very complex tasks, which artificial neural network, the see, for doing these kind, for example, I'll tell you, there could be a problem of, suppose I have to recognize digits from 0 to 9, for example, right? So this can be done by drawing a simple neural network, okay, right?
Okay.
So we would keep, so artificial neural network again would have number of techniques, number of algorithms, right? For example, you might start learning about back propagation neural network. In the time, you might talk about competitive learning, right? You would talk
Mhm.
about Boltzmann learning. There are many algorithms in artificial neural network. It's a broad area, but deep learning has a specific thought process which only talks about huge network of neurons, which talks about many layers, which would actually process or would tackle those problems which are very complex in nature. For example, I would say recognition of, say, suppose different objects into the picture or in the video, or for example, automated car systems today that we know, right? We can talk about,
Mhm.
I mean, the video processing, we talk about all the complex problems that you see around, right? So these are actually the outcome of through deep learning approaches. So artificial neural network again is a bigger perspective that talks about many algorithms, right? Deep learning is one of the approaches to achieve learning the way human does, right? But that's the not only approach, right? Human can learn in many other ways. So that talks about, that entire analogy talks about is the artificial neural network, and deep learning only talks about very specific problems that requires huge processing, that talks about huge network of layering, right? With the time you would be able
Yes.
to understand that what I'm trying to say, right?
Yes.
So whenever there is a deep learning, when I say the artificial neural network, deep learning is a subset of artificial neural network. So it means that in artificial neural network, there would have been many other ways, many other
Okay.
approaches. But artificial neural network would always talk about learning in the same manner, the way human does, right? Solving a problem in the same manner human does, right? When I talk about machine learning, so solving a problem only the way human does is not the only approach that machine learning talks about. You got my point? So artificial
Yes.
neural network would always talk about the way human solves a problem, the way the human brain approaches to a
Works. Yeah.
solution, right? You got this
Mhm.
point? Yeah.
Yes. Yes.
So
Yes.
I
Sir,
have
can
Yeah.
one
you
thing.
Yeah.
please expand on
One.
the symbolic AI? Because you mentioned that it's kind of getting outdated, but rule-based systems, for example,
Rule
let's
based is
say,
very simple. Simple. In an older days, for example, even still today, right? So it would be if, else, then kind of statements, you can say, very simple. If a situation occurs, right? Production rules. There were some, I'm not sure whether you have talked about export systems or not, right? If such thing happens, then if condition happens this, then what would trigger? If another condition would happen, then what would trigger? So it was basically a kind of concept. So if a rule follows, if a rule triggers, then one of the actions associated with it would trigger, right? Another rules happens. So earlier,
Voice
the
is
concept
not
of
audible
learning
to
was
me at all.
Sir, your
is it
voice
same
is
for everyone?
breaking.
Oh,
Yes, sir. Yes, sir.
just wait. This is little. Hmm, just wait. Let me see, because network
It is
says
clear.
that it is. Hmm, it is clear now.
Yeah, yeah, very clear. I think I'm able to hear you very clearly, loud and clear.
So I mean, my network shows pretty good. I mean, it is giving good speed as well. Anyway,
sir, I don't think your network is a problem. Please proceed.
yeah, just
You're
wait.
audible. You're good.
Yeah. So moving on to, let me give little bit of thought processes on this. So I gave you a little bit of thought process on rule-based systems. So similarly, I mean, still we are using it quite a bit. Search and optimization algorithms. Still, I mean, say for example, you have to So if learning is not the approach, I have to search something. Suppose in a room, a bigger room, I have to search a needle. So I do not need a learning approach to solve this problem. That is a smarter approach I need. So what approach I would use? So it would be an algorithmic approach. So in AI, there are something called heuristic algorithms. I'm not sure whether you know it or not. We would not actually go into that much details, otherwise it would become difficult expect for me to cover on the topics, basic concepts. So search and optimization is an algorithmic approach which artificial neural networks were using, because AI is not a good new technique. It is coming since 1950s, right? So to a greater period of time, search and optimization algorithm was one of the techniques, major techniques to make the systems intelligent, sorry, smarter, right? So it does not talk about making a system intelligent. It talks about making a system smarter through rule-based systems, through search optimization techniques, similarly through knowledge representation, reasoning, planning these systems in a better way, right? Evolutionary algorithms, you must have heard about that survival of the fittest theory, right? Charles Darwin. So evolutionary algorithms talks about those methods, right? Well, let's not go into too much of details, otherwise, and fuzzy logic systems where it talks about that uh, there are statements called fuzzy statements. If I say that x is taller than y, so it is not a crisp boundary, right? How much taller, I'm not talking about, but still human mind is able to process that kind of thought processes, right? So but the machines are binary, so they do not understand tallness. We have to give the definition of tallness or um, biggerness or goodness or whatever, right? So still human minds are able to process, or not, sorry, not human minds, still we are able to process these kind of things. That is fuzzy logic. So fuzzy was one of the major techniques which came as a revolution, in 1980s and 90s actually, right? So when the systems got intelligent in a way that we used to embed this fuzzy behavior into my chips, right? So fuzzy logic is another one way of achieving the systems smarter, right? But since then, when the concept of machine learning came in, the concept of deep learning came in, artificial neural network have come in. So the AI is broadly looked into the domains of machine learning and deep learning only, but which is not the truth, right? So that was the thought process. Okay.
So I
Bit,
can say safely
yeah.
that machine learning provides the learning in the way the human perceive the learning, and
Not
then
exact. No, 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 no. Not exact definition. No. When you give this definition exactly for neural networks, not for machine learning. Machine learning is a broad method. So
okay.
it talks about the way, it talks about that learn through data. Machine learning would always talk about that learn through data, right? Learn through data. And when you learn through the data, not only the way human, when I learn from the data, so it's not that always the way human would learn from the data is the only technique. There can be other techniques as well. You got my point? But artificial neural network
So
would always talk. Yeah.
so
Yes.
artificial intelligence is on top of machine learning to make decisions, right? So decisioning is
No.
happening at the artificial intelligence layer, or
No,
it
no,
is
understand my
throughout
point.
the.
No, 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 no way. Understand my point. See,
Sir, can we
machine learning,
understand these like the subfields of the AI, right?
obviously, that's what I'm talking about. So, please understand the thought process which I gave you. The first thought process I gave you is intelligence. I gave one definition that making a system smarter, right? And in the thought process, I told if I have to make my system smarter, one major chunk is that I do it the way human learns, or where the human is doing, or the human intelligence is one of the major thought process, right? But there are other thought processes also where I have written other approaches. Machine learning talks about, again, in order to make my system smarter, the best way is to learn from the data. So machine learning would always talk about making a system smarter to by the way of learning, or by the way of learning from the data, right? It starts talking about learning. Machine learning talks about learning, right? So when I say learning, so it is not the human learning which is the only way. There can be other ways in which the things can be learned, right? So supervised learning, unsupervised learning, reinforcement learning, you learn from the environment also, right? So it's not the only way a human learns. Even a dog or animal or other species can also learn from the environment. Understand my point? But so when you're learning from the data, it is machine learning in a broad category. Artificial neural networks specifically talks about learning the way human does, specifically. So when you talk about the way human learns, it is very specific to the neural network. You got my point? You did understand the thought
Yeah,
process?
yeah, got it.
Yeah. So actually, most of the places, I mean, sadly, everything has been well, directly linked with the human learning only. No, it's not. It is not the only creature which is intelligent, right? So let's talk about this three basic concepts. Although you have got the little bit understanding, so it talks about the science of making things smart. So that's the basic definition that you must learn. It's not that the way human learns, you would find those kind of definitions most of the places, that artificial intelligence is only about the way human learns. No, it is making a system smart, right? It's a science basically. So the aim is to make machines perform human tasks. So again, majorly, major of the tasks would be the way, because that's the major task. Most of the problems I would like to solve for humans, right? For example, robot cleaning room, right? So yes, since it is solving most of the problems for the humans, therefore that human nature or human thought process comes every time in between. Okay. So machines performing tasks intelligently may or may not learn. So I've specifically mentioned these two terms. Please understand every time, right? Like robot vacuum. I mean, these are some of the examples that you always know, right? Traffic light control system. So obviously, you do not need any kind of intelligence at this point of time. Chess engines, for example, right? So again, there are many good algorithms. Earlier also, I mean, there were not learning mechanisms involved into creating the games like this. Rule-based customer support bots were there previously also, right? On the other hand, machine learning is an approach to AI, definitely. And machine learning, it learns or performs the task through learning by experience. So again and again, I've told you, it learns by experience through the data. I have missed that particular line, through the data. So data becomes the prime oil over here. So it's a prime oil or engine oil over here is the data. So unless you have data, you do not talk about machine learning, right? So these are some of the examples. With the time, you would also learn, right? Like where the learning. So here, the learning mechanism, all these examples, learning mechanism would be used, right? Okay. So key idea is what? System improves using experiences. And the best idea is that, or best thought process is that it would keep on improving as we keep on increasing the data and improving the data. Understand the point? Like this, I mean, you would have heard about this. Uh, uh, I mean, these engines that when you train the systems, they would keep on increasing. They would keep on achieving better and better accuracies, right? Isn't it? So, I mean, these systems would keep on improving the way you would keep on improving with the data and could keep on increasing the data as well, right? So that's the thought process. Deep learning, on the other hand, is a technique for implementing the machine learning to recognize the patterns. Obviously, the thought process is that I want to understand something more deeper. I want to recognize the patterns, right? So most of the problems that you would look around, which revolves around DL, would be around recognizing the patterns, understanding the features, understanding the different kind of features, right? So deep learning is what the key idea was be learning the complex patterns. And learning the complex patterns is not possible in every case through machine learning. I'll talk to on that later on, right? I cannot learn very complex patterns through the approach of machine learning every time. Why I would talk about that, right? So, so when it comes to complex problems, complex understanding of the say for example, you have thousands and thousands of images, right, on different objects, and have to recognize different objects from these thousands of images. So that is where a simple machine learning approach or even the complex machine learning approach may fail. So that is where the deep learning neural networks would come into play. And deep learning neural networks are a complex structure in the same way that a human brain is, right? So examples would be face unlock.
Could you
Yeah,
please give me a real life example which will work on the DL
yeah,
concept?
yeah. Yeah, it is coming. See, so face
Yes,
unlock
sir.
system, for example, right? So in a mobile system, you have a face unlock system. So it is like anyone could lift your phone and there would be multiple presentation of images, but it is still able to recognize your image itself, right? So any kind of face recognition system that you developed today, it's not that the face recognition system were not developed by simple machine learning algorithms before. There were different kind of algorithms like SVM and many other ensemble techniques that we use to create such kind of things. Please understand one statement. Any problem which is solvable by deep learning can also be solved by machine learning, but it might take even thousands of years to solve a problem by machine learning, which deep neural networks are able to solve within no time today, right? So deep neural network have that kind of capability where they can process the complex features, the complex tasks which a brain can do so, right, within no time. And this is because of the parallel processing that goes around. And this is mainly because of the advent of so powerful machines that we have today, especially the GPUs. You must have heard about it, right? So one is face self-driving cars. So self-driving car is a problem which cannot be solved through simple machine learning algorithms. It requires very, very complex processing and all those features, mapping and handling, right? So it is all through this deep learning techniques today, right? And deep learning today has also advanced from to great extent these days. You must have heard about transformers, isn't it? Have you? Isn't it? So transformer is the biggest, I would say, powerful machine these days today. So it's not that the deep learning has been the old age deep learning. Deep learning has also evolved quite a bit, but the concept is deep learning, right? So we would obviously understand about what are the different concepts in deep learning with the time. So voice assistant system, Alexa, Siri, these all, if you remember, I mean, if you understand, these systems have improved with the time. Alexa, you keep on training Alexa, right? It would keep on learning and learning, and with the time now it has learned so many things today, right? It is able to answer many questions which you might not have trained also, right? So, but it has got trained from other perspectives or other systems, so therefore it is strong today. Similarly, chat GPT like systems today where it can generate many good things, right? So NLP systems. So DL is used when data is huge and patterns are complex. So that is something that you must understand, right? So as far as the data is simple, patterns are not complex, we do not use deep learning. Machine learning approach would be sufficient, right? Did you get that understanding little bit of it, right?
Yes,
So
sir.
let's delve a little bit more into what exactly deep learning is, right? A bit more, although I have gave you a clear picture. So what is deep learning? I told you it's a type of machine learning based on artificial neural network and which has multiple layers of processing and used to extract progressively. This word is very important. It learns the features progressively. Suppose as a human, I have to recognize a picture, for example. Suppose that picture is 30 years old, right? So it's not that by looking that picture at once, I would be able to solve it. We might feel that I have solved it immediately, but first I would have logged, my brain would have worked in what manner? My brain would have first extracted the bigger level of features, right? Maybe I would have understood the face patterns and all those. Then I would have got deeper into that particular face. I would have got more deeper into that particular face or image, and then ultimately my brain would have recognized it. Although things have happened so fast that I'm not able to understand this complex or the layered base of learning, right? So when it learns the features, because I have to understand something, I have to recognize something, it has to happen progressively. So that is what deep learning learns the features in order to recognize something in a progressive manner through different layers. I would talk about that obviously in the coming sessions when I would talk about the structure of deep learning, right? So it is inspired by the human brains, I've told you. Yeah,
Say multiple layers. Why not
yes.
one or two layers? Why is
That
it
I'll
different?
tell. I'll tell you that. It is too early to talk about. For example, there's an image, right? So the first, see what happens is these layers would actually, I mean, these layers would give you, say, I'll give you a very simple analogy. Suppose you have to Suppose the example could be that you have to recognize a particular image, right? By looking particular image, you know, you have to get deeper. Say it is not a human brain, first of all, right? Human brain somehow being so complex, how it works, we doesn't know. But God has given us so much of efficiency that we are able to do it within no time, right? Now, when it comes to machine, so obviously when I have to recognize a particular image, so I have to do in step by step. One step could be that I have to draw the boundaries. I have to understand the boundaries part. So one of the levels or one of the layers would work on the boundaries part in order to diminish rest of the portion of the image, right? Another level of the layer would talk about understanding the core features of it, right? Maybe suppose the color portion or anything else. Another layer would talk about much other deeper details of the image. So every layer talks about or works at much detailed features so that ultimately I'm able to recognize that particular image, right? So it's not I mean, since it is a binary, I mean, system-based analogy, and the systems work at behind the system. I mean, this concept. So they would not be able to process the entire image at once. It would work in phases. So that is how. I mean, we need layers, right? So it keeps on extracting more and more details. That's what you can say. Every layer extract much pure details at a next level, right? So I told you that inspired by human brain, these networks are designed to recognize the complex patterns in unstructured data. Obviously, when we're talking about these kind of data, these are all unstructured data, right? So that is also one of the easiest way to understand the difference. If I'm working on a structured data, so probably I would have never used deep learning techniques. Yeah. Okay. Structured data means what? Data which is in the form of rows and columns most of the times, right? You must have CSV files or DBMS files. You must have heard about it, row and columns, right? So as far as the data is structured, you probably are done with simple machine learning algorithms. There are many machine learning algorithms. The moment we have unstructured data where the things can be very complex, that is where the human brain kind of processing becomes more important, and that is where the deep learning comes into play, right? It's not that the unstructured data cannot be handled purely by machine learning approach. Let me tell you very clearly, right? Like for example, if there are simple text files which is unstructured data, right? I mean, I can do it with the machine learning approach, but it takes so much of time, it takes so much of processing that having a solution with that kind of processing may not work, especially when the data is huge, right? So deep learning is ML technique that teaches the computers to do what comes naturally to humans, that is learned by examples. Deep learning is a subset of machine learning, which essentially is a neural network with three or more layers. We would come to that particular part when I would start talking about the layering structure of the deep learning, right? So deep learning gets named from the fact that we add more layers to learn from the data, learning in a more and more details, right? Deep learning powers many advanced artificial neural net applications today. We would talk now. It uses structures called ANN, right? We would talk about this. Each layer learns something different from the data. So that is the key idea. You know? So you might look, I mean, deep learning might look, these neural network, you might see, you must have, I mean, seen this otherwise also, I hope. So you might see artificial neural network like this. You must have heard about it, you know? You must have seen. So you might see connections between these neurons. So each of these are neurons actually, right? We would come to that. There's a complete dedicated chapter for it. We would talk about this later on, right? So right now I'm just covering the basics part, right? So each layer. So this is one layer. This is another layer. This entire is one layer. This entire is one layer. This is entire is one layer. So these are layers basically we're talking about. So every layer, so this layer might understand or learn one kind of feature. For example, it might learn the boundaries of the images. This might talk about some other feature. It might talk about the color aspects of that particular boundary, or might talk about some other feature. This particular layer might extract much detailed part of that another features, right? So but every layer would learn deeper into the overall data that has been given to me, right? So the first layer learns basic details, the middle layer learns patterns or the shapes, for example. The last layers would learn the complex ideas and decisions. So this is how the things work, okay? So the more layers we have, the deeper the network becomes. The deeper the network becomes, it becomes more and more complex, and therefore it is basically the name deep learning. You got a little bit of an idea. So even if you're not able to get how it is structured, why it is structured that way, obviously the things would come later on. Okay. So I've given a simple example, right, in this particular case that would give a little bit of understanding. Suppose you want to teach a child to recognize a dog, and what you do. So the first time the child looks at a picture, they notice simple things like the dog has eyes, ears, and all those major components, right? After seeing a more examples, they start recognizing dog usually have fur, tail, and bark. So this can be done at one layer. For example, this learning the student has achieved at one layer, for example. Another layer of learning happened at the another next level of layer, right? Later they can tell the difference between dog and a cat also. So this has happened at another layer. So that is what we are talking about, deeper into the layer, right? So it's not that the child would have learned everything about this dog, and it would have started recognizing a difference between the dog and a cat or other kind of animals in the one instance. It would have done that in a structured manner, right? So that's the thought process. So deep learning does the same thing. It learns by example, improving as it sees more and more data, right? So obviously, if a child has to recognize that whether a dog is different from a cat, so it would have been given more and more data. It would have been given, the child must be presented with many different kind of dog images or many kind of different dogs images to it. It would have been given many different kind of cat images to the child so that he can clearly distinguish between a dog and a cat, right? And can start extracting the different features for cat and different features for cat, right? So that is how, I mean, the deep learning also work in the same manner. Why deep learning? That is more important point, right? Yeah, someone has raised the hand. You can talk.
So,
You can come. Yeah.
yeah. So essentially, it does it have to be more and more data or a same data set, but I go in iterations. Like I learn a small piece and then
So data often would be given in one instance, right? Data should be present in one instance itself, right? And then the processing goes in step by step. So I cannot process the data once in a once
one
instance
iteration.
itself. Yeah.
Yes.
So
Thank
you
you,
are
sir.
absolutely right, right? So why deep learning now?
So if I may say that, like
Huh.
if I may see it here, so as compared to the ML structured data. So the data, whatever would be provided for this deep learning. So is there any difference between those? Means like I'm talking because machine will only learn about the numericals, I believe. So then it's like is it the same way that it used to extract like the vector and all? And then
Yeah,
after that,
absolutely.
is it doing some more addition, or therein I am actually confused that where is the difference, or from where the start of the difference is between structured and this unstructured assembling of the data. If you can
Do you
tell me.
understand? I hope you have a very clear understanding with structured data and unstructured data, right?
Mhm, mhm.
Yeah, you have. So the the level of
So
processing,
structured
the
data, yeah, I mean, like if I can say that the structured data is arrangement of in the same sequence, same ordering, same everything, whatever
rows and columns form,
follows,
mostly
right?
rows
Yeah,
and columns form,
right.
CSV
Exactly,
file,
exactly,
and that.
exactly.
So structured data is there, and these are some are called unstructured data, right? Images and videos, whatever you know. So when it comes to structured data, so what happens is, say there's something which is very important is called feature extraction. You understand features, isn't it? Features, right? So the
Yes,
columns
yes,
that you
yes,
have in your data, these are features, right? So
yes,
what
Attributes
happens?
collection.
yes.
Yes.
Attributes, you can say, right? So at this stage, I mean, it could be little early, but let me tell you. So
Okay,
what is the problem with machine learning that I'll tell you? You know, it's not only about the structured or unstructured data. It's not that the machine learning is incapable of handling the unstructured data. First, clear that very clear in your mind. It's not the case actually. It's about
okay,
something else.
okay.
The machine
Mhm.
learning finds difficulty when the issue with the machine learning is that it has to extract the features manually. You get my point? Suppose there are thousands of features. There's a data where I have to, so suppose I have to handle images at a very large scale. So I might be talking about many features. There are many features that I have to deal with, right? But the extraction of features, that which feature is good or bad, which feature should be kept or which feature should be left, this is a manual task. This is something which needs to be done by a data scientist or whoever who is handling the data. And this becomes a very hectic task. You get my point?
Yes,
So which feature is important or not, this handling this particular aspect becomes very complex. For example, if you're using an automated car system, for example, right, the self-driving system, so there won't be a less data, there would be enormous amount of data, enormous amount of features that would come along, right? So handling those features beforehand, which feature has to be taken or which feature has to be left, has to be done manually before the build-up of the model, before the algorithm actually builds up. So this is something which is a serious dis, I would say, kind of a limitation when it comes to more of a complex problems where we are talking about, for example, image handling and a video handling and whatever the problems that we are talking about, very complex problems where huge amount of data, huge amount of features. So that is where the deep learning actually stepped in, right? So in deep learning, the handling of these features or extraction of those features is automated. The human does not do it. We do not have to do it beforehand. So with the time that we would learn, right? So deep learning is able to extract those features from those complex layers of patterns, right? So one level of feature might be extracted at the base first level of layers. Another feature might extracted at a second layer. Another feature might get extracted third layer of the deep learning. So similarly, those features get extracted layer by layer. So that deep comes into play. There can be the networks where we have thousand such kind of layers, thousand deep layers. Okay, but again is someone people like you might come in immediately and said that, sir, this would be very time consuming task, isn't it? No one has given that thought process, because if I'm doing at such a level, so definitely I could see that there's a huge computational task which is happening, huge computational task which is happening behind the scenes. So that is where the modern machines of today, where GPUs that work, I mean, in a parallel and distributed manner, So because of the advent of these huge and complex, powerful machines that we have today, the deep learning models are successful. Otherwise, we might have taken millions and billions of years to solve the problem that we are able to solve even within no time today. Believe me, right? Even to do a face recognition system, it might have taken thousands of years. That is the kind of structures or the complexity which is happening around the in a deep learning networks, right? But the machines are on the top of it today, right? We have huge progress in terms of the power, and that's the reason. And let me tell you that these neural networks at once upon time was a dead machines or dead algorithms most of the time. So, are you aware that these machine learning algorithms came when they were invented? I mean, the classical machine learning approaches they invented in 1960s, 1970s, 1980s. But by most of the time, by 2000, I mean, these algorithms were considered to be absolutely dead. Why? Because the machines weren't very powerful. It is only after 2010 when the concept of these core machines or powerful machines, and especially the GPUs, when it got into the system, when these dead machine learning algorithms or the deep learning concepts actually came alive. Okay, so that's the thought process. I'm
So,
audible? Yeah.
yeah. So deep learning do not require any data science, or they require less amount of data science involved in it.
It's in a different way. Now, data science is a broader terms. So data science not in a typical way that you are expecting, right? That cleaning and all those aspects. No, all those aspects are actually so everything got automated. So that all headache is not yours, right? So obviously, when I'm talking about feature engineering, so it does not involve feature engineering, right? Obviously, it does not talk about cleaning of the data and all those stuffs that we used to do in machine learning. So obviously, it data, but since it is data enabled, right? So data science plays little bit of important role in terms of that the presentation of the data, right? The
Yep.
architecture, building of that architecture, that aspects would definitely come into play. Yeah.
Thank you, sir.
So
So
moving
then,
ahead,
then one
yeah,
one thought actually provokes me now. So
yeah.
then in that case, why can't we use this ANN or this deep learning everywhere? Why we are then
I'll tell
using
you.
one more
I'll tell
layering
you.
of the
I'll tell.
structure
I'll
and
tell
yeah.
you. So suppose I have a apple to cut, right? What would you use? Sword or a knife, right? So you would definitely go with a knife, right? So it depends on the kind of problem that you have, right? So what happens? I'll give you one analogy later on in the slide. So when you start taking deep learning, right, it is not that easy to, first of all, just forget about the implementation part. So normally deep learning starts responding well when you have good amount of data and keeps on increasing, right? It is a similar way a supercomputer definition is. So you would start saying that why don't we use supercomputer in every place? No. When you start using supercomputer even a smaller problems, it would rather give you bad results, to be very true, right? It would only perform when it would have that kind of structure which for which it was built for, right? It would start performing well when you have huge amount of data. And the deep learning, in one of the graphs I'll show you later on, that it keeps on improving as you keep on increasing the data. As the amount of volume of the data and the complexity increases, then only it starts keep on improving, right? Otherwise there's no use of such kind of complex structures, because when you talk about complex structures, a lot of, I mean, arrangement that happens, right? A lot of computations that happens, right? Isn't it? So it's no, you can always use it definitely for a single problem. For example, digit recognition, from 0 to 10, 9 digits recognition. I can display it, I can solve it through a deep learning approach also, but it's a waste of resource. There's no use to it, right? Though we cannot, there's no need of it. A simple machine learning algorithm would have done it, right? So that's the thought process. But today, since everything has been automated, I mean, without knowing, people start employing transform or even to a very single simple model. So it's not that it would not solve it, but there's no need to it, right?
एक आग
So
में
that's
लिख
the
के
only,
दिया है 5 minutes break
yeah, 5 minutes
इतना
break.
वो भी हंस रहे हैं सर
I didn't get it. You talk about break. Should we continue, please? So we'll talk about why deep learning,
Yes, sir,
right?
please. Let's continue.
Yeah, please.
Yes, sir.
So,
Continue.
so I give you a very now the same question that why deep learning? There's someone who was asking. So first of all, be very clear in your mind. If I do not have large volume of data, there's no definition of largeness. First of all, I'll come to that. Right? It's the same way we talk about big data. If someone say that how big, when I would start calling my data to be big. I hope if someone has worked on the concept of big data, they know it. It's not the when the data would be in terabytes or petabytes, then when it is not about the amount, right? It is the complexity and the volume of the data that makes it. Lots and lots of unstructured data like images. So I'm giving a scenario where deep learning would be useful, right? Cheap and high quality sensors, right? Today, which enable us to capture this kind of data, because of which the length and the volume of the data getting increasing. Cheap computation is happening today, right? CPU, GPUs, distributed clusters, because of which the data can be collected so fast, right? Cheap data storage devices that we have. We can learn by examples, augmented features. I mean, I'm talking right now that what is, I mean, tempting towards this huge amount of data, and because of which deep learning is becoming so important, and I mean it has become kind of a compulsory kind of weapon for every most of the applications today, right? Scalability is one of the bigger issues. I mean, most of the things that keeps on increasing, data keeps on increasing, right? Within my phone, for example, I mean, it would keep on increasing the data, right? So scalability is a very important thought process that I have to deal with. So automated fee changing generation, something that I need, right? Advanced analytics needs to be applied. So let's break this into a little bit more structured way now. So obviously, deep learning should be used when I can automatically learn the complex patterns. I do not need it manual intervention, the way we used to do in machine learning, right? So where I can extract the patterns automatically, like whether images, text, or so every extraction or automated complex pattern extraction happens automatically with every layer, right? We would learn that when we would start picking up the first neural network, right? So without any human intervention, right? The way we used to do in machine learning. So traditional machine learning needs you to tell what we look for. We used to do all those stuff of data handling, feature extraction, everything we used to do it by our own, right? So deep learning, however, it is able to find the right features by its own. It's learned directly from the data. So medical image diagnosis, for example, and like for example, in earlier methods, radiologists had to define features like tumor size, shape. These are features. So I do not have to do these feature naming and extraction of features through manual interventions. That would happen automatically, right? Or the only thing is you have to give the right amount of data, the right I mean images, and everything would happen. And obviously the algorithm that you have written, or the deep learning algorithms that was working behind the scene, needs to be mapped correctly, right? So it would be able to extract these without our understanding. It would not tell you that this is tumor size or shape. It would take care of everything automatically, right? Isn't it? So network would automatically learn to detect the patterns or diseases. So how it would do so, I does not know. It is in the same way, the same answer, like how I'm able to solve, how the human brain is able to solve such a complex problem. I do not know
Voice is
myself, but I'm
breaking.
able to solve it. I'm able to understand it, right? The same way,
Sorry, you're breaking.
deep neural network, I would not others also.
Yes, sir, it's
Same,
breaking
sir.
up. Right?
The voice is breaking
Yes,
forever.
yes.
Yes, sir. It's
It
breaking.
is it is breaking.
Uh, Still, it is
It's
not clear.
on and off, sir. It's good now. It's good now, sir.
Okay, I
Sir, I
have
have a
to
question
think
on
something
this.
about. Yeah, yeah, please.
Sir, so humans, they are able to make decisions based on learning, evolution of learning, right? Someone introduces a thought that, hey, this is a cat, this is a
Understand.
dog, right? This is a
I'll quote.
rice. Yeah.
No. Understand. Understand.
Yeah.
Let's stop you in between.
Sure,
Humans
sir.
not always learns through examples, first of all, right? That is one way of doing so, which we call it as a supervised way of doing so, supervised learning, right? Human learns through unsupervised learning also. Humans learns in a way, reinforcement learning is done in that way also. So human is a power machine which can intermingle all kind of learnings together, right?
Yeah.
If I'm not
Yeah.
trained for something, still I'm able to solve it, right? So that kind of structure that I have. Now
Mhm.
your question,
Okay,
please.
sir.
Uh-huh.
No,
Yeah.
So
no,
I have,
makes sense, sir. Yeah. Thank you.
Yeah.
I have a question. So when we
Yeah.
talk about the layers that we define in a deep learning network, right? So is it something
Hmm.
that humans define it, predefine it, or do
No,
the algor
no, we do only one thing. Um, I'll give a very simple analogy and then I'll give the answer. Like, for example, I'll just build up, suppose I have to develop a society. So I'll just give the architecture first, right? And how the people are going to occupy each of the houses, that's not my problem. Now coming to the technical part. So what I'll do is I'll give up the structure, right? I'll create a structure. A structure means that how many layers I have to define, right? The connections I'll talk. I mean, too early, but there are connections between each and every layer. We call them weights, right? So how what is the initial learning that would go around these weights, which we normally use in random way? There are many other strategies, right? So in a way, very simple analogy I'll give you. We define the architecture definitely, right? And then how we define some of the basic rules, right? Basic rules means that how each of the neurons would activate it or deactivate it. There are certain given analogies and rules, right? There are different activation methods. I'm sorry. There are certain interventions we can do it through parameter tuning and all those, right? We normally call it learning rate, and there are a number of things I'll tell you later on, right? Other
Sir, we
than
upload,
though,
sorry to interrupt, sir. Sir, we
yeah.
upload all
So
these X-rays or MRIs, give my
yeah,
neural network
yeah,
all the information, but
yeah,
I have
yeah,
to
yeah.
give some supporting information as well, right? What does it
Absolutely,
mean?
absolutely. So those supporting information, that's what I was telling. So these supporting information you can talk in terms of parameters of certain important components, because since everyone may not be have seen that structure of neural networks, so I'm little cautious in saying those words, right? So structure with some kind of information, as he rightly said, or parameters, initial parameters. That is the only thing that I have to give, right? Rest, I'll also talk about that how those parameters, how that learning should be done, how the errors you understand, because if I'm giving something, so it might learn, it might not learn. So how that learning would take place. So those methodology also I will give you. That thought process also I'll give you. For example, I may teach a student that this is the way you have to proceed, and if the error comes, this is how you have to behave. So I'll give that thought process also, right? So if the error comes in, how you would deal with that error, how you would try to reduce the difference between the target and what you have to achieve. So these things I'll give. So these are part of the algorithms, parameters, initial thought processes that I'll give to the neural networks, because everything cannot happen automatically. Come on, right? Isn't it? So and then the how those values gets calculated and all those, that is not my, I would say, or how those features are getting mapped with different layers, that is not none of my business. It would happen automatically, right? So it would need little bit of more understanding as we go along with each and every network. But yes, not the way we used to do in machine learning, right? I would not invest all my energy into extracting those features, that this is this feature, this is that feature, this feature should be linked with this system, that system. That I would not do. Okay. So, I mean, coming back to another thought process, deep learning handles the big data very nicely. It is able to handle this complex and the big data very nicely, and that's the reason why deep learning exists today. Otherwise, there was no need of no. So obviously, we are producing such a huge amounts of data, whether images, videos, speech, sensors, data, etc. So this is one of the reasons why deep learning exists today, right? So self-driving cars, I've given the examples. Similarly, why deep learning exists is deep learning understands the natural languages, right? So with the NLP task that has become a must for today these days. In every aspect, we are there's hardly any difference between how human talks to the machine, right? So I mean, deep learning understands the natural language task very nicely. As a result, there are huge amount of data which is existing, which is ambiguous, which is contextual. So again, the deep learning models like transformers and many other complex methods come into play. So the existence of deep learning is all because of these reasons. Because had there not be I mean, if I would not have started processing the natural language, right? So probably the deep learning would not have been such a popular models today, right? So majorly because deep learning is trying to process the chat GPT is the greatest example. I'm talking to the GPT because the way I'm talking to a human being in a way, right? So it is all about natural language processing. So virtual assistant chatbots, right? So these are the reasons I'm talking about that why deep learning has become so popular. Deep learning creates a new things also. Everyone knows that generative AI has become the new way of learning, not learning, a new way of uh, uh, I would say computation and new way of doing the things today, right? So, I mean, so these are the reasons why I would not go into details of these because everyone understands that what these tools are, right? So it creates a lot of possibilities in design, education, entertainment. So moment that, so ultimately what is happening if you see everything is giving rise to more and more complex data, right? It is making the things more and more complex. As I told you, when the things become more and more complex and getting more and more, I mean, complex, the deep learning would always thrive and survive, right? And that is why these things are. Similarly, accuracy is obviously one of the issues. Humans, in spite of such a complex machine, would never be able to process the things the way. I mean, these deep learning methods are able to do so. So this is one of the reasons, right? Similarly, deep learning keeps on improving with the data. This is one of the most important things that deep learning in a way has an advantage, right? Human mind or human brain would not have that kind of capability. So as I told you that as the data is increasing, how these chat GPTs and GPTs came into being, why didn't it came so earlier? Because with the time, with the advent of data, it keeps on we kept on improving this data. We had answers to each and everything. Google was working on it, right? Google, I mean, we everything was there. But when everything was there, at that point of time, the GPTs came in where we were able to intermingle all your things which are kept separately. They were able to link up all those data which was kept separately. Otherwise, earlier with the Google, it was only search. Now it is not the search which is only there, right? So therefore, deep learning would keep on improving with more and more data, with more and more complexities, right? As the time would come. Deep learning enables automation. Yeah, definitely. You understand this. Automation means that you, once you write the algorithm, once you write something, you do not have to again go back and change that algorithm, right? As you would keep on improving the data, it would be able to solve and understand, would be able to take that particular context and would be able to solve the newer solutions. It would be able to give newer understanding once the data is added. In the same way that Alexa is works, right? So once Alexa, you keep on giving the data, it has been trained only once, algorithm has been written only once. So it is able to take care of new data. It is able to solve the new learnings also. It is able to take care of that, right? So I mean, what I'm trying to present is that why, because of which deep learning is becoming possibility that it would be there in the time to come, is because of these and these aspects, right? This would give you a little bit on thought process that you can see deep learning works better when you give it more and more data, right? You see this particular line when we're talking about large neural networks, we would call them as a deep neural networks, for example. I'm talking about medium neural networks, I'm talking of small neural networks, I'm talking of traditional neural networks here. You can see that with the traditional neural networks over here, you can see it improves the first, you can see the improvement is first, but with the time, as you keep on increasing the data, it has become a stagnant, right? And its performance becomes almost a kind of stagnant. With the deep learning approaches, with neural networks, large networks, see that it would keep on increasing, it would keep on improving. So this graph gives you a little bit of understanding that why deep learning is there to stay always, right? Right, just a thought process, right?
So
That
this
would
performance
always.
is basically your accuracy.
Yes, absolutely. So the performance keep on improve. That's what I told you. Someone told that why not use deep learning everywhere? No, deep learning would perform better when the data keeps on increasing, right? Right. Obviously, when we're talking about data, it's not that it would be always a rubbish data or I mean, we're talking about data which is good enough, right? So if the data is increasing good enough, then it would keep on improving its performance, and that has happened. Otherwise, why none of you or why have you ever thought about the way how does this I'll give you a simple analogy, the mobile phones. Do you think that the technology has increased or is changing so fast that my phones which were 10 years back and now or maybe 2 years back, just because of increasing the RAM or increasing that little bit of structures, I'm able to handle such heavy images, videos? Is that the thought process, or is it just because of this little bit of increasing the hardware? Still, I'm able to do so? No, it is because of the model which is working behind the scenes, the neural network models or the deep learning models which is working behind the applications. Otherwise, see, I had a say suppose 8 GB RAM to 12 GB RAM, even 24 GB RAM if I'll create it, it is not going to create so difference. It is the algorithms which is working behind the scenes, where otherwise these all your hardware would have come to shut down, right? So it is the algorithms or the neural networks or the deep learning networks behind the applications which are working. They're becoming more and more powerful because they have learned so much, right? So this is a simple
Sir,
timeline. Yeah, please.
Pankaj sir, so sorry to interrupt. But
Yeah.
initially, we thought the data would be given only once, and the algorithm for deep learning will do it iterations, or it will learn with
No,
that data.
data we would start with some data, obviously. You know, we would start in the same way human does. We start with some learning, right? Data would keep on adding. Your algorithm would not change. Your algorithm would not change, right? It would make adjustments according to the data. It would make adjustment that I would say parameters. And they again you do not have to intervene that. They would keep on changing automatically. The data would keep on increasing, right? And the performance ideally, if everything has been structured nicely. Obviously, it all depends on the structure, the architecture that you built first. If the architecture was not scalable, things would fail. You understand? So if
Yeah.
you have the right architecture, it was scalable architecture, it was rightly built, it was rightly parameterized, or parameter tuning was done rightly, wasn't it? So things it should be able to scale, it should be able to handle this data, bigger and bigger data. So that's how I mean the systems are. So it's not that see, probably we might start thinking that neural network is such a easy task. No, plug and play. No, it's not a kind of plug and play. It's a huge investment in terms of how you design the network, right? It has to be scalable architecture. It's not that you do not need the efforts, right? But
Sir,
somehow those, if yeah,
the
yeah,
amount of data that we feed progressively, right, to these deep learning models, uh,
mhm.
the neural network gets expanded, right?
No, 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 no. You do not, the layers does not get expanded automatically. Understand my point? No, 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 no. How does a layer? Architecture, it's a part of architecture. Na? If you have built up a 30-acre design or building, right? Architecture would remain same. Na? Architecture would remain same. It's not that the layer would automatically get set it up automatically. It's not something. How can that be done?
The
How
layers would
can
be fixed, but I mean, so it has to store that or it has to
no? It does
persist
not
that
have to store
information.
that. No, no, no. It doesn't have to store that. That's the beauty. It does not have to store, right? Storage is not a thought process we're talking over here. You know? It's a processing thought process, right? Storage. So I tell you, say, do not close the entire boundary in terms of storage. Also, would be taken care of by these new networks. No, storage is never taken care by these new networks, right? So every problem would creep in otherwise. So it is not the storage. Yeah, Ravi Verma, who please.
Yeah. So if the architects, when you say scalable architecture, and I was thinking like it was a follow-up question to the question what was asked before. So if it's not scaling the layers or the neurons, like how it can adapt the new learning, like how it can go for a
Absolutely. It is adaptation to the new data. And obviously, learning is happening automatically here. So adoption of the new data, and you can say learning also, obviously. So it is the adoption to the newer and new data and learning, right? So you don't have to go back and change your I mean, the networks or the architecture or the learning rules. You don't have to do that. Yeah, please. Someone else also raised question.
Based on whatever we have discussed, can we say that instead of storing the data, like that's not something a part of the architecture, we are rather storing the weights, and with new data that comes up, the weights is updated?
Obviously, otherwise how would happen? That's the blood. The bloods are not going to flow into the veins. So since I was not talking about all these things because I'm not sure about everyone is at the same level of weights, and with the time, maybe from the next session I would start talking about these things, right? So yeah, it's the weights which is the everything. So it is about the weights, which is the all learning what goods will get stored, all those learning what is happening would get stored
What
into
is
these
weight
weights only.
here? What is weight
So
happening?
that's the reason I was trying to little bit apprehensive. So give me next lecture. Otherwise, I have to break in different thought processes. I have to first draw a network. Then I would be able to explain. So weights, in a way, you can think about in a very simple analogy, the human does, right? So the the flow of blood which is going into your veins is a weight right now. That's what I would say, right? So if you're alive, whatever we're doing, other functionalities are working, but if there's no blood flow of blood, things would stop abruptly, right? So all the learnings which would happen in the neural network would be in terms of numbers, you would say, and those numbers would be somehow would be represented through these something called weights that we are talking about. Okay, we will talk about this. So let's not get into so haste, otherwise, yeah, you raised the question, Ravi.
Yeah, sorry, so I have another question. So uh, if we produce our DNN with a particular goal, the DNN grows as per the data that is being produced at a later point of stages, right? When we ask more question, when we feed in more data, it grows with its knowledge, correct, to make the right prediction. And let's say,
Absolutely.
so if the goals getting changed on the way, like if we are trying to adapt more further learnings for a different, would that introduce a new architectural
So
change?
again,
Will it be?
that would require absolutely. See, obviously, if the it is you would design something for a set of defined goals only, no. So if you abruptly change the goal or the goal set is absolutely different, then it requires a change in the architecture. Surely, very surely.
Yeah, I mean, it's not like we introduce it. But if the users like they are introducing, if they are prompting with a new question that is not relevant to the model, I mean, or the goal what we introduced.
See that. So again, again, try to separate that. When we're talking about this prompting and GPT context, है ना, that is a different context, right?
Okay.
GPTs, you cannot simply say that we're talking about learning. GPT is on the top up of all these things, all the data which is kept there, right? That is a generational model, right? These are not so obviously transformers and neural networks are the tools because of which GPTs. So it is the use of those high powered transformer models because of which it's a concept, right? Prompt engineering is a concept, right? So right now we are talking a different thing. Right now we're talking about a learning, right? So when we talk about generative models, that's a different concept. So let's not mix that thought process. It's a different
All right.
process altogether.
Thank
Yes,
you, sir.
Sayan, yeah.
Yes, I'm sorry, I just have another question. So we're talking about how how much the bigger the data or the more the data, the better the model is. But in this case, are we also filtering the data before sending it for training, or is there some kind of data science that is there, like pre-processing or something?
So filtering and all those filtering, everything would be taken care by the system automatically, right? So there's some called right? Because with the time, if we would keep on increasing the data, keep on increasing the parameters, the way we are talking that more and more data, the things would become very complex, and at one point it would be difficult to process everything. So yes, inherently, system takes cares of those filtering, stopping some neurons and nothing along something. There's a kind of dropout and all those. There are a number of thought processes which are there, but the system takes care of that thing. But we explicitly does not need to do any kind of filtering, in between. But system does take care of it. Otherwise, the things would become very, very complex. Yes, it does. Right.
Thank you.
So, I mean, this is a timeline which would give you. I mean, I'm not sure it like. If anyone would have started learning, it would have started learning through this macular split. As you can see, it is not a new concept. So it would came in 1945, right? And then the first, I would say, in a way, which involved some bit of learning mechanism. So this does not involve any learning mechanism. Macular split model, right? It was a hit and trial method. 1950s when Hebbian learning came into rule. So there was the first thought process of learning came into play. We'll talk about that because none of you asked about that, how learning happens, right? So that we would talk about, right? So learning
Sir,
happens
actually,
by, hmm,
sorry, sir.
yeah.
Yeah, I wanted to understand on that terms only. So suppose we have a base model with some limited knowledge.
So
Uh, uh, yeah,
we'll
a
give you,
neural network
I'll
is
give,
already.
yeah. So give us some time, maybe a second, because I have to give you the present thought process of it. I have to explain the structure. Otherwise, I would just give there is something called weight updation rule. Right now, I can tell you this. Now, learning happens by adjusting the weights. How the weights gets adjusted is the learning rule. So, I mean, may not get that right at this stage. So maybe in the next session, we would be picking up the first learning method. We would start talking about perceptron. We'll start with perceptron. So the first neural network, which actually was a true learning mechanism, was the perceptron, and Frank Rosenbelt is considered to be one of the godfathers of neural network, right? So this is where we would start with, and just see the year when it came in, right? Then Adeline came. So we would talk about perceptron in our understanding or everything. We would solve these problem also. We would solve backpropagation. Backpropagation is a kind of mother of all the neural networks, I would say. Everything that happens today, even the best of best, I mean the transformer models. So every thought process. So if you are able to learn this backpropagation very nicely, right, you would be able to adapt to any of the neural networks. So that would be one of the major thought process that I would present, right? And then when there's long history, they have, so CNN we would cover a little bit of it, right? We would talk about LSTM definitely. We would talk about transformer models. Obviously, nothing, everything cannot be discussed as per the syllabus, right? Then obviously these days, chat GPTs, you know, So ChatGPT is an arrangement. Understand my point. I'll talk about in one of the session if possible. So ChatGPT is more of an arrangement, right? Everything was there. So it is just like that you had super machines around you. So everything was arranged in such a intelligent manner that you're able to arrange them and start solving such a good problems today, right? So let's talk about applications of deep learning, which should not be very difficult. You can always take up this. Everything that happens today, majorly around digital world, it is all the applications of, I would say, neural networks or specifically the deep learning network, speech recognition, automated. Everything that is happens around mobile is a perfect example of deep learning these days, right? Automated human, this translations and all those these kind of things and automated recognizing the images. These are typical applications of deep learning, right? These are typical learning. So GPTs and everything. I mean, you neural networks is become a bread and butter of today. I mean, I really hope. I mean, if we suddenly, I mean, these deep learning are nowhere, then most of the life would become absolutely a different life, maybe 20, 30 years back. So key components, I'll give you a little bit of an idea of key components, which you must have good thought process on it. So what are the key components of DL, right? One is the data, which I would say is an oil to the entire machinery from where we are going to learn from, right? The model, this is the architecture, I would say, right? The architecture that I try to draw a very simplistic architecture, like how the arrangement of neurons would happen in layers. This is the model, how that connection would happen between the neurons. That also matters a lot. So that architecture that I'm going to draw, that model, yeah. Please switch off, whosoever. So that model is important. Architecture at this stage when we talk about DL, right? We used to talk about model in machine learning also. So machine learning also, we used to talk about that model. In that machine learning, we used to talk that model in terms of the function. Okay, function of xi. Xi is what? Features, which used to give me the output. So what function could be applied on those set of features to get an output? Here, the model would look like an architecture which can be ultimately be converted or can be figured out in terms of a function. It's a function approximation. I give some input, I get some output. So how that input has been dealt with, processed, is being processed mathematically through a function. Okay. So model is a kind of function, it is a mathematical function. Then objective function, that how the difference is, the target is what I'm expected, that is the target, and what I'm producing, suppose yi. I'm producing yi and my target to achieve is t. So what's the difference whether I have achieved my target or not? That should be my approach. There would be always some difference. So this objective function, which is a mathematical function, it would quantify that how badly or well I have been able to achieve the target or not. And continuously, I have to ensure that my model goes near to the target, right? Because I want to remove those errors. Because as long as what I'm producing and what the target is, there's a lot of difference in terms of these two. So there would be errors. So I have to remove that. So this objective function would take care of that error and would try to. So I have to apply mathematically so that this function improves minimization, I would say, minimization of error, right? So the algorithm which would work in order to minimize this function, by adjusting those parameters and everything, that algorithm would be there. So in a way, we have the data, we have the architecture, and we have, you can combine 3 and 4 together. So we have the objective function linked up with the algorithm that would try to minimize the error between the produced output and the target. And I want to ensure that I'm as near to my target, right? Isn't it?
So
So that
both
is the overall, yeah.
the objective
Yes.
function will optimize, or the objective function will quantify.
It would quantify, obviously. Optimize, algorithm would try to optimize, right? And it would quantify, obviously. Objective function will always quantify, definitely, right? In terms of values, obviously.
So
So,
algorithm will
yeah,
optimize the parameters so that objective
yes.
function can
Function
quantify and
gets,
can
yeah,
basically
yes,
report it
yes.
better.
Yeah, absolutely. That's why I told you it can put this three and four together, right? So obviously it's some algorithm. We would normally use algorithm called gradient descent. With the time I'll talk about that. So you give the data, the model will make prediction losses. So basically objective function are the loss functions, to be very frank, right? So loss function will tell you how wrong that is, and the algorithm would update the model. And this process is not a single uh, process or single step process. Someone audio is on. Please take care. Someone's audio is on. So let me give
Sir, what is
data.
loss
I think
function? I have heard this term first time.
I'll just give me a minute. I'm coming to that slide. No, we'll start with the data first. So data everyone knows, right? So data, I mean, it would be in terms of features. You can have multiple features, xi, x2, it can be terms of multiple features you might see, right? It can be a single, I would say, array representation. It can be multi-array representation. It can be very complex, and data can be anything literally. It can be coming through the sensors. Ultimately, everything needs to be quantified first. So data needs to be quantified. That everyone should take care. Everyone should get it very clear into your head, right? So it needs to be quantified. Okay, only quantified. I did not talk about that it needs to be, I mean, it needs to be we would not do too much of, I would say, it would be converted into a specific form, but you don't have to invest your time in cleaning that data and doing all those stuffs that we used to do with machine learning, right? So obviously, and it's a supervised learning mechanism. So I need to give examples. So I must have labeled for each and every data. So I can represent it with the input and with some target, right? So this is how mathematically I can represent my data. Now, this is one of the very simple examples. It's a structured mechanism. I mean, to understand the things, we understand very nicely with the structured mechanism. So it's not that I would be able to handle these kind of data only by deep learning. I told you that most of the data would be unstructured. But having said everything, I have to present my system would be able to convert every kind of data numerically. It has to get converted into numerical understand. The features needs to get converted into numeric form, right? So, I mean, that features can be as complex as possible, but so very simple term. Like these are the features you can see, bedroom and all those location, square feet. I mean, this is how you must have done a neural network as well. Sorry, machine learning as well. So just wait. Where's the pointer? Yeah. Just wait. Where the pointer has gone in? Yeah. As you can see, that these are the features, and this is the target value. So X features and target. So this is the thing that I would give to my system. And accordingly, once I have my data in whatever form, whether structured or unstructured, I have little bit of, obviously your understanding of the data should be there. So depending on the understanding of my data, I would create a model. I would create a structure, or I would say architecture, right? We will come to that later on. I'm just giving you understanding about the data now. So data has to be there. Then model, right? Model, although it might look very complex, it would be arrangement of layers. How many layers? So that arrangement has to be there. And with the training, with the more and more, I would say, experience, a person would be able to map A person who is able to map in conjunction with the data, he is able to create a correct architecture that matters the most. Yes, Ravi, you want to ask something?
So my question was on the data, like we point, I mean, in the diagram, we were pointing the target to be part of the features, but in data, we
Yeah.
say we separate out the target. Is there a reason behind it?
We just repeat
So,
this. We
so when we represent the data, you said D
yeah.
equal to X comma T, right?
Yeah,
I
yeah.
think the feature and the target, if I'm not wrong,
Yeah,
correct?
labels. Yeah.
But in the example diagram, what we represent at the right side, we included the target along with the features.
See, obviously, there would be two aspects of any algorithm, right? Or any method. So one is training. So when the training would happen, or when I would make my system learn. So I have to give the features along with my data. That is the target. And when the system would done, right? Then obviously I would give some unknown features to my system, and it should be able to produce the output, which I would see whether it is correct or not, right? Actually, I didn't get the answer. So obviously, because I'm developing a system. So if I'm developing a system, I have to give the features and I have to make sure I have to also give him the answers. So it is targets are the answers, labels. So what you have to learn. So what my system would do is, so here my system would try to learn the features. Say suppose bedroom, I'll say suppose X1, I'll call it X2, and suppose this is called X3. So I'm trying to develop a system where I want my system to learn these things, right? And produce the target or the Y, whatever I can call it, right? So
Yeah.
with
So
this
sorry,
system,
sorry for
yeah,
interrupting. Like my question was like, when we produce the data, we produce the data. I mean the features and
features,
targets separately, or is
yes.
it like we give the data in generic, like it contains both the feature and the target feature as well?
Normally
I
give
mean,
the conjunction. Yeah, we'll give that in conjunction, right? We
okay,
see it's all representation, right? Obviously.
okay,
So
okay,
mathematically, I would give in conjunction form, but obviously I would deal features first, and for every feature, I would have a target in the same manner that I could show you. So this
okay.
particular row, it would has must have a target value, right? Yeah.
Yeah, yeah. Thanks.
So model, I told you, over here the model would be the architecture that we would be producing or we would be creating actually. This architecture is something which the one who is developing the network has to build, right? So you would see this might be a little complex at times depending on the problem. Then the objective function I told you. So objective function basically would be the loss function, right? So loss function here would be, I told you that there are target value and there are the output which we produce, right? For if see what happens for each value, when I would process this particular row, so there would be a target value, this, and there would be a value outcome that I would produce. So suppose yi. So what is the difference between yi and this target value? I need to minimize it. Similarly, when I produce this particular row, again for the same thing, it would produce some yi and it would have a target. So I have to again remove that error between yi and that target value. So this process gets continued. For every row, for every piece of data that it would produce an outcome, and what is expected, that is a target, that needs to be minimized. Because when I would start minimizing this between target and the produced output, that is where I'm making my system improving and I'm making my system learn, isn't it? And that function, whatever function that we would talk about, that is called loss function. That talks about the minimization of this error between the target and the yi in every aspect. So it's a mathematical treatment basically. So that is basically we would, so there are good number of loss functions that you would learn with the time, you know. So different type of algorithms, classification algorithm would have different loss functions. Regression has different loss functions. So different kind of methodologies are there. So this loss function is a mathematical model actually, right?
So
And I
I
would
I
let you know.
lost you for 5 to 10 seconds. So if you can just
Okay.
explain again this objective
Okay. So
function in more
loss,
detail.
yeah.
Thank you.
So objective function, I told you that for every iteration, like for example, I gave you this particular example, right? So I told you that for every iteration, we have a target. For example, if I'm processing this particular row, for example, I'm processing this row, right? So the target value over here is this. When I'll process this, I'll get some output, right? Okay. So when I'm going to process this particular row, I'll get some output where the target value was this. So the output which I received, suppose Y, and the target, suppose 520K, there might be some difference. So my function, loss function, would first try to minimize this error, right? It would try to minimize this error. How it does, I'll tell you at this point of stage, you would not understand. That is something called back propagation of errors, or many mechanisms are there, right? So in that iteration, when it is trying to minimize the difference between the target and the actual output, that process, how it would do it, is called the loss function, right? So it would try to, so in order to minimize it, there can be different ways of doing so, right? So that loss function has to be associated, right? So I have to talk about that loss function. I have to objective function has to be defined, and there can be more than one objective function which are possible, right? So how that loss would be managed, you know, and obviously
So
I
if
would,
I may say that this objective function will vary based upon how we are getting the
obviously,
data, means like vary in terms of the loading. Like if I have, let's say, 10 parameter, now we know that it had varied for some of the percentage
so rather I
or
would
something.
improve this. No, I would rather improve it. Objective function would vary according to the type of problem and the type of, I would say, the way the data needs to be handled, right? It's not that, so one kind of network would might suit to one kind of objective function, another kind of system or network might suit to another kind of objective function. So that again requires the statistical as well as the greater understanding of the mathematical aspects, right? And people can do experimentations on these things also. They might try different optimization functions, sorry, different objective function, and see that which objective function is able to minimize the error between the target and the object, the yi, in a lesser number of iterations, right? So most of
So
the things
from one
in,
layer to from one layer to another layer, this objective function would be
no,
same as you
no,
have
not from one layer.
drawn the
No, no, not
circles.
actually. No, no.
Okay.
It would be little early. It's not from one layer to another. It is from within. Suppose if this is a piece of data, right? So just forget about layer over here, right? So this is one row I've given, and this is the target value. So when I give this particular piece of information and the target value, I'll try to minimize, and suppose in one of these statements it gives you suppose answer 1210, and here the output is suppose 310. So I'll try to minimize this error before actually processing next statement, within this step only, right? I would, so my objective function would try to minimize the difference between this and this first before reaching out to and start processing the next statement. So that is how, see, that is how you are learning, no? If you are taking, suppose, new things, a child is learning first lesson. So when he has learned first lesson, so you would say that first lesson is learned only when you have minimized that error. Then I will, so every data piece is chapters, you can say. You learn first chapter, minimize that error, then you have minimized that error. You cannot minimize the error to zero, obviously. You know, it is always some kind of error is left, or some error is always. I would say that I would achieve at least 5% of error, at least that is acceptable. That has to be also defined, right? I'll tell you later on. So, so
I have a
from
doubt
chapter
here.
to chapter, from row to row, you would keep on improving. And in every chapter, in every iteration, you have tried to minimize that error. So in a way, every piece of data is learned in such a way that you have learned to minimize that particular error. You know? So this is called basically this. So suppose this is the 8 piece of data. So I would call this as an epoch. I would call this an epoch, right?
So, sorry to
So
interrupt you, but I have a question here.
yeah.
As you said, we have to minimize the error between the target value and what we get in the result.
Huh.
If we minimize the error for the data fifth, after that,
Hmm.
we will go to the next data, that is six. And now here
Hmm.
again, we minimize the error and we change
Hmm.
accordingly our objective function. That changed
No, no, we
objective
changed
function
no, no,
will,
no, no, understand. Change objective function would remain same now. Objective function change क्यों होगा? Objective
like
function
we
तो
are
बना इसलिए
updating
हाँ,
we are
update करेंगे.
updating
Yeah,
objective
yeah,
function to get the
yeah. Hmm.
minimized error.
Yeah.
At the same
Hmm.
time, when we have a updated objective function for the data 6,
Hmm.
so this updated function will increase any type of the error for the previously data, that is 5.
It can happen. Yeah, it will happen. So this is not the only way. There are different
Okay.
ways of optimizations, right? So this is just one generic way I told you, right? Just to make you
Okay.
understand. So there
Okay.
are thousands of versions
Okay.
around it, you know. So that is just one way of the most easiest way I could explain the way child learns. Now
Okay.
that's why I named
Okay.
that it is chapter the 8 chapters, right? There are thousands of
Yes.
ways which exist in theory, right? Which how
Yes.
would you update it? It can be updated like I could have divided the entire 8 chapters ki jagah I could have developed it. And suppose I would have said this is 2 chapters. This is block 1, B1, this is block 2. So let me train all the 4 and then whatever error comes, I would try to remove, optimize it. That is one, right? And then
Yes.
I'll again train next 4, whatever error comes in. So this is kind of batch optimization. That's why I'm not telling in great details, otherwise all would get confused. So with the
Okay.
time, we
Okay.
would come
Okay.
around it. Okay. So
Yeah.
there are these are
Okay.
these methods would come in. Don't worry.
Thank you.
So the idea is very simple that you have to minimize. The only thing that you need to understand is minimize the error. Because if you do not minimize the error, and with the time, no one will teach you how to minimize the error, then learning is nowhere. No, learning means, you know, what you wanted to learn, target. If you have started learning minimizing those errors between what you are getting and what target was there, that is the learning is. And in order to do so, every time weights would get updated in a simple way, right? So let's not waste too much of time right now. It is just like, see, I mean, these are the data points you can see on this particular figure, suppose, right? These are the data points. So P is what, this, sorry, the line, this is the uh, this is the line that you have drawn, for example, right? Right. So, and these are the data points. So suppose this is the line that you have predicted or whatever. So there is always, it's not that it is coinciding all the data points, right? So these, whatever is there, this is the error that you are getting, right? So error is something which would always get. So you could have gone with another set of lines. So another line would have been much better fit to it, right? So I mean, with the time you would learn. So let's not get too much into details. Otherwise, another aspect is called, I told you, that is learning algorithm, right? That how would you learn? I mean, learn means how would you update this weight? I told you that whenever there is an error, updation of weight would be there, isn't it? Weight would get updated. But how would you update those weight? By what rule? In what manner? What would you apply? Again, this would be a mathematical thought process, isn't it? So that thought process is defined by the learning algorithms, right? So learning algorithm capable of searching for the best possible parameters for minimizing the loss functions. So popular method is gradient descent. We would probably do this maybe third session, maybe, right? So these are, I mean, we would be using number of optimization algorithms like foundations. When most of the algorithms actually it is these are the foundation. Whether we would use a batch gradient descent, stochastic. I'll talk about this. What I was giving an example to ma'am who was asking this, it was this only. Whether we are updating in a batch-wise manner, right? Whether we're doing one sample at a time. I was explaining one sample at a time. Then I gave an example that let us do it batch-wise, right? How would you update? And how would you update that error? So that depends, right? So this would be there. Then again, although I mean the need not to be covered, but just to give an idea, there are other methods also. Momentum based method. You add memory to the past updates, So momentum. I mean at this stage you do not need that. Adaptive learning methods are also there. If someone of you must have worked on I mean ML algorithms, ML, right? You must have seen something like this. I'm not sure behind the scenes. So Adagrad, RMS prop, right? Adam, these are some of the popular algorithms which adaptive learning rate methods, right? Similarly, there are second order optimization methods. So a lot of mathematical aspirations are there, right? Newton method is a well-known method, right? Regulation and optimization tricks are also there. Although it is not an algorithm, but there's a trick basically. So how would you minimize? So it is not that you apply an algorithm and things would be done. No, right? So you have to apply certain techniques. Dropout technique is there. Dropout means that at that stage you might get confused that while learning I may not involve all the neurons in between, right? I might because some of the neurons might learn. For example, if you're training a set of 100 students and suppose 50 students are already learned, so why would you ask them to and next time, and obviously there's an error. So when you're trying to update the weights, and since the 50 students were already doing good, so you would not touch those 50 students. You say that you don't now learn. You have learned, sit back. I'll make other 50 students learn. So that kind of that 50 students who are not been involved, it's a dropout, something like this, right? So weight decay. So there are a lot of mathematics involved. Neural network is not at all an easy system to learn. So it is it's a complete mathematics actually, right? And it becomes very complex. Transformers and all those these concepts are very, very, very complex, right? Anyway, so I mean, how do you create a model? You design a model, you grab the new data. That is a simple. I mean, that is what everyone has neural net. I mean, in machine learning also, you know that you always design a model. You have a data, right? You keep on updating that model and check whether that model is good enough or not. We have already talked about. You need to train the model also, right? You train the model. You develop the model, then you train the model, right? And once the parameters are finalized, we call that it is a model. So it is a step-by-step method, and once that model is developed, right, and once you have trained that model, and it means training means what? That you have set the parameters, you have set the weights, learning, all the weights are learned. You have set the weights and you've set the parameters. Parameters, there would be number of parameters. I later on you would come to know that learning rate is one, right? So the number of parameters. So your weights are set, learning parameters are set. Then you give a new input. Then the new input would get through the same processing, same step of processing, and then it's expected to give good answers. But you would never say that it would give the correct 100% correct results. You never know, right? But the overall thought process that you have trained your network in such a way that it would give you minimum error. Okay. Uh, this is something everyone knows it. I would not go much details. So supervised learning is one, right, where you have both examples and the target value given to you. You would be given both examples. That means input as well as output. And then you would learn by formulation of the function between you would create a function so that you can learn the connections between this x and t, each x and t, and you would be given many examples of it. So you would be given many examples, and you would, on based on those examples, you would develop a function f(x to t), that is a function of these are the features. X are the features, single feature or multiple features. And then once you would develop this function f, then obviously you can give some new xi. You can give some new xi, and it would give a value. This value should be as correct as possible if the system is, and if you develop the network quite well. So this is how supervised learning work. So many examples of classification regression would come into here, right? Similarly, unsupervised learning, you only give the input. You only give the input part. You do not have any target given. So when you have the data input, so obviously since you do not have the target, so the statistical methods or the algorithms would try to see the relationship between the data. The similar kind of data would be grouped into one cluster. Another similar kind of data might be grouped into another cluster. So that kind of thought process would happen. For example, you have multiple documents on internet, the multiple documents are being produced. So there must be some clustering algorithm or unsupervised learning behind working behind the system, which tries to club the similar kind of data. All the music related data gets clubbed into one folder. Another, all the sports related data gets clubbed into another folder. So that kind of clustering or document classification method is working behind the scenes. I hope you must have heard about these things before. Reinforcement, you're hearing my voice, right? You're getting voice?
Yes. Yes.
We're just going to
Yes,
close,
sir.
right?
Yes,
Yeah.
sir.
So reinforcement is another different kind of thought process, because you cannot expect that you in supervised learning that everyone would help you, because in supervised learning you have been given the data and you have been given the examples, but every time you would not have that particular thought process. No one would give you perfect data, because there's a perfect, I would say, example where you have the data available with you, right? Isn't it? So supervised learning is a very ideal scenario, most easiest scenario, where you have what? You have the training examples. Unsupervised learning, I mean, you do not have any examples with you. You only have data. So you can do some kind of clustering and all those things, right? Reinforcement learning, again, these two approaches seems very good for people, maybe humans, right? When it comes to non-intelligent creatures, for example, right? For example, if I talk about a dog, now a dog does not learn, you know. You cannot expect him to learn from given examples. You cannot also expect him to learn from simple data which you give it, right? So they would have a different mechanism of learning. In reinforcement, what it would give is you need both kind of intervention, supervised intervention as well as unsupervised intervention. For example, dog learning something, then the master would do what? It would give him the task, you know. It cannot explain him the task, but whatever he wants to make a dog learn, it would. So every time it would, when the dog performs some actions, and if master sees that it is doing the correct action, it would give a reward to a dog, right? So eventually dog is not completely supervised because he does not know the target value, because he cannot understand it, but some kind of supervision was there. So in search of that, so there's a searching which is going in the mind of a dog, right? In order to get reward, it would start searching the right path. The dog would start searching the right path by its own. So it is learning by itself, learning from the environment. No one is making him learn. It has given him a kind of, so it is trying to get a search by its own, and search of, so it would start building the algorithm in its own mind, you know. And in the mechanism, in the process, we would say that dog has learned because now it has started performing the way I wanted. So this is a mechanism, reinforcement. Every time, trial and hit error. You try once, if it is okay, that's good. If it doesn't okay, then again give you next iteration, it will try to get into a right path, something like this, right? So reinforcement learning is very, very common in robotic actions, robotic mechanisms, where because you cannot because those machines are not intelligent by itself. So based on that task, you reinforces its learning, right? Yeah, Ravi, you was asking something.
Yes, sir. So I understand theory like we reward and punish a particular
Yeah.
model, like, but actually how we do it. I mean, when we say the analogy, we can think like how a dog is getting punished or rewarded, but the model,
So
how
again,
we provide that.
so again, this is something where they're given thoughts, mechanisms, and algorithms which are defined reinforcement. So it is basically that it's agent-based learning, right? Where it learns from the environment, right? So at this point, it will be very difficult for me to teach you how the reinforcement learning takes place, right? So it
Okay.
actually interacts from the environment, and so I mean, again, the mathematical situations again would be there, right? But in a different manner. So you would find losses and everything, loss function, everything there also. But at this stage, it would be difficult for me to take you. Well, no, you
That's
define it would be action-based mechanisms, right?
okay. Yeah. Thank you. No worries. Thank you so much.
So we would not go into these details. So the second chapter we would try to catch up, if I'm not mistaken, would be on first neural network. Maybe perceptron should be there, right? If I could remember. And we would try to learn that how a neural network works behind the scene. We would try to see how in action neural network gets developed, right? Okay. So good enough, I think, for today. So
So it
I'll
would be
do
a
what?
theoretical class next week also.
Next would not be purely theoretical. See, if you want, it's all up to you, right? So at some time, at some portion, all students starts talking about, sir, what is important from exam perspective. Just teach us whatever is good for exam. See, so I can give you a lot of implementation files. Now it would be your interest whether you do it or not. I'll give you ready-made Python files and all those things, and would explain new ones, right? And then interest would be yours. I'll give you a lot of implementation aspects as well. Sayed, you wanted to ask something?
Yes, sir. I have very basic question here. Like, as you showed the data set, right, for house price prediction. So on that, we train the model, deep learning
Yeah,
model, and then the model starts predicting in the actual production environment, right? At that time,
yeah.
I don't know what is my actual value, right? So then how can I incrementally train the model? Is it possible or like we stop at once we are done with the prediction? So that's my
So
question.
understand there are two, understand, my dear, there are two phases, right? Just let me give a little bit of an idea. One is your training phase, right? And other ways is your when you have, so training phase, what you did is you gave a lot of examples. That is, suppose this is X and this is suppose Y. That is output, right? So in every example you had what? Your input and Y, isn't it? Isn't it? So you started training it for each and every sample. This is sample one, sample two, sample three. For every sample, you try to minimize that error that I told you, right? So with the time, what you developed is when the training is done, you would have developed X function of X to Y. You would have formulated mathematically this function. Okay, got it? With every training pair, you would have. So what has happened after first training pair? You would have developed some function, right? After second training pair, you would have adjusted this function. After third training pair, you would have readjusted this function, right? This function might look like what? If I say that, it might look like, suppose, ax plus of b in a very simple way, suppose. This function might be like this. So there are two constants which got learned. So after first iteration, A and B value would have adjusted something. When you have given second iteration, A and B would have again readjusted. After third, A and B would have again readjusted. So what you did is you drawed many lines. This is nothing but a line equation. Ax plus b is a line equation. You draw first line, then you readjusted, another line got drawn, another line has got drawn, another line got drawn. So, but you had the data points. Data points were the actual points. So what we are trying to look at was you were trying to fit the best line on this data so that minimum error could be obtained. So in every whatever data you have, if you had good amount of data, you would have got the more possibilities to adjust A and B in a better way, for example. And once this is done, once you have formulated AX plus or B is equal to Y, then what you need to do is that once this function, that function is what? That function is now actually AX plus or B. Once this function is developed, what would you do? A and B value got developed. So you have to just give new value of X. So you would give new value of X, A and B would be formulated, you would put this into this, and you get a value Y. And that is what the output is. And whether this output is good or bad, it would completely dependent on how A and B correctly was formulated. So this is the thought process. You got this?
And are we incrementally updating the weights after we go live for the production after training, sir? Like if the user is not satisfied with the prediction, suppose.
Obviously, then in that case, that different mechanisms. One is since you were not using, you didn't have proper data, so increase the data, increase more data. Yeah, increase more data then, right? That was the case. That could be the case when underfit model was underfit, right? Otherwise, there are other regulation techniques. Yeah, someone is asking something.
ये दूसरे सर पढ़ा रहे हैं, एक साथ ये पांचों सर पढ़ा रहे हैं,
Okay.
एक का लेक्चर अटेंड कर सकते हैं।
एक का लेक्चर हो गया।
अच्छा, okay. Anyways, you got this?
Ashish.
Please. Yeah. So this is how we do it. So whenever you feel that I'm not happy with this new value that I'm giving and the output which is giving is correct, then either you increase your data because you have to readjust the model then, right? Otherwise, there could be the case when the model has overfitted. I know, because that involves machine learning approach. Overfitted is that not only learn from good things, you also learn from the bad things. You learned not only signals, but you also learned noise levels also. So in that case, again, you have to see that I mean there are regulation techniques that we use and we reorganize that model. I know we try to improve that model by using those regulation techniques. But ultimately, you have to come back to the model and either you improve that model by increasing the data or either you improve that model through optimizations, parameter optimizations. So that is what the most you can do it. And if you have mapped completely wrong thought process, for example, I was doing classification and you was mapping it onto regression model, then it is your mistake. Then you have to come back. Patel, you want to ask something?
Hi sir, my name is Ritu Patel, and I
Is
wanna.
someone raise your hand, please?
Yes, Ritu Patel myself.
I'm not able to hear.
Yeah, Professor, one question, Rohit here.
Yeah.
Hello, am I audible?
Yes.
So yesterday in the machine learning class, we were
Hmm.
introduced into the concept of IIDs. The data set needs
Hmm.
to be identical and independent and identically distributed. Does the same assumption
Absolutely.
hold good for deep learning as well?
No, not at all. No, at all. No, that is not at all a worry point. You know? So it is only talking about collect the data, whether it is absurd data, whether it is good data, bad data. The only difference would be that if it is a bad data, it might take more computations, more, I would say, computational involvement of the system. It might take a lot of more time, right? You are not worrying about it, right? The only thing which you need to take care is that you need to give the data as per your required model, required architecture, sorry, right? That's the only thing. For example, if you have drawn a network like this, so suppose if you have given, you're developing a model of recognizing digits, for example. So you have given that um, all my, this is the first layer that suppose you have done. So the first layer requires that you needed a data in the form of an array, and where I needed suppose 10 features, x1, suppose xi, x1, x2, x2, and x9, suppose, right? So only thing that you have to ensure that you give the data as per this structure, that is 9 piece of information. one row of information, which would go into my first layer of the architecture. That's the only thing that you need to worry. What these x's are, how they are interdependent, whether two x are completely same, whether they are dependent, not dependent, that is none of your worry. Got my point? That's the beauty of neural networks. Yeah.
Got it. Okay, thank you.
Hello,
Yeah.
I'm audible,
Yes.
sir.
Yeah. Right now you're audible. Yes.
Yeah, I want to know that you will provide us a assignment, right, sir? So in that, what kind of questions and like it is based on theoretical or a program, or and how should
Don't
we need
worry.
to prepare it?
Don't worry,
By
bache.
like
Whenever,
hand,
don't worry. Don't
like
worry.
is it
Whenever I
handwritten
got a point.
text?
Don't
Yeah.
worry. So whenever I'll give an assignment, it would be not that I'll just give an assignment. I'll explain you what I've given, right? So as such, I mean, we give you support material, right? We give you support material. Assignment would be the case when I would give you and I will take a test. So that assignment would happen, whatever as per the scheme, right? I'll give you many sample things, many working examples I will give you, which would be similar to what you would get in your exams, right? So that would be covered as a part of the PPT. Then I'll give you certain practical implementation aspects where you will get those practical. So maybe that may not come in exams, but would be very important for you to learn in a better way, right? Otherwise, that PPT are good enough to get the overall perspective from the examination viewpoint. Okay,
Or sir, in
right?
examination, in mid examination or in a comprehensive examination, it is
Mm.
enough to prepare this PPT material, or we should need to
Yeah, so
prepare
whatever
PDF.
they would give you, they would give you some sample paper also. So it would be a bit of numerical questions, bit of it would not be any kind of what is this, define this, that kind of question paper does not come, right? It only talks about certain kind of analytical way as well as most of the time it would be numerical based. So we'd come to know. Don't worry. Why are you so worried about it at this stage? You would
Actually,
get
it is
everything.
very new to us about like AI
Everything. So
type of
when you
question.
studied for the first time in class one, it was also new. Now you are grown up. This is also new, right? So don't worry.
Okay, okay. Thank you,
Sir,
sir.
Okay. Yeah.
sir, in open book test, we can use these PPTs which you provided over the Takshila.
Mm, I'm not sure. I mean, you can put this query to the coordinator. I think you can. Not an
Yeah,
issue.
yeah, we put this question for operational team. They told me that you have to ask for the respective
You
handler.
can because there is an open book that means everything is your choice, no? You
Okay.
can take
Uh,
open book. I mean, I'm not sure how it open book happens at
yeah,
because
actually, we
right.
also knew for it. That's why I'm asking the question
Mhm.
which material we are allowed to
Open
use.
book means open book, right? Open book
Yeah,
means
but
open
they
book.
are
I'm sure that.
operation
Huh?
told me that you have to use only those material which provided for respective subjects. Uh,
So obviously
No,
PPT would
actually,
be there. Yeah.
yeah, during
Yeah.
orientation, we had been told not this PPT. Before exam, there will
Okay.
be few PPTs which will be shared that we can
okay,
take to the open book exam.
Okay.
Yeah,
okay,
not this one.
Okay.
Yeah.
okay,
Good.
okay, okay. Thank you,
Okay.
thank you.
Okay. Thank you. So should we end today, right? So we'll end today's session, right? Thank you, everyone, and we'll meet in the next session, right? And I'll try to
So
put everything in. Yeah.
sorry to interrupt, sir. So last thing,
Yeah.
I was going through the handout. I could see that we were supposed to complete XOR problems and precipitable learning algorithm. Are we
That
expected
no,
to go through
don't
the
worry.
reference?
Yeah,
Sir,
you
I
can, but
want
obviously this would be covered in the next session. I mean, they have put
fair
this,
enough.
but I mean, we have got another PPT which we used to follow, right? So that we get weekly basis. So in this, we were supposed to cover till this. XOR and this would become quite lengthy, cannot be covered in the single session, right? So don't
Sure,
worry, we
sir.
are following what we have been given, right? So
Okay.
whatever was given to us, to me, for today's session, that was good enough also. And this could only have been covered. Otherwise, this is the first session I would started explaining too much. It would have become too lengthy and bulky for you, right?
Yes, sir. Yes, sir. Agreed. Sir, are we
Yeah.
supposed to prepare something before the next lecture, apart from the what you have, taught today?
You're expected to get the understanding of what we did, right? And I mean, I'm always open to the questions. So whenever question comes, it's not an issue. You can always do uh, reading. You already have that handout. I mean, in terms of class, what are the syllabus is. So you can
So where is
always
this
learn,
handout
come
we have?
prepared.
Handout is where exactly we can see?
You can
You'll see that in
see all those
Takshila.
things, Takshila, right? Please. All right. Okay.
Oh,
Thank you, sir.
let me check.
Yeah. Thank you. Thank you, everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Hello. Hi. Hi everyone. Is anyone there?